Hello student. In today's session, we start new article from chapter 1, measurement, uses of dimension analysis. This is very important article in exam point of view as well as in any competitive examination point of view also. Now first use, let me start with the first use. Total three uses of the dimension analysis we have to learn. Out of that, the first use is dimensional analysis is used to verify the truth of physical equation. It is used to verify the truth of given physical equation. Now, what exactly it means? It means that if any equation, physical equation given to you, if that equation is dimensionally true or not, that you can decide by using dimensional analysis. Now, let's see some examples so the idea about this first use will be clear. Now, here we are using a principle of homogeneity of dimension. In this, we are using principle of homogeneity of dimension. Means if equation is x is equal to y, x is equal to y, it means that x and y having a same dimension. This is called as homogeneity of dimension. Similar manner, x plus y is equal to z. X and y, they are added, it means that they having a homogeneous dimension. Because you know that mass can be added in mass. Velocity can be, means force can be added in force. Similar quantities we can add. So x plus y is equal to z. It means that x and y both are similar quantities. So here we are using a principle of homogeneity of dimension to verify the truth of given physical equation. Now let's see one example here. So let's see example number 1. So in this example number 1, a well-known equation. So this is a kinematical equation. It is given v square is equal to u square plus 2s. Everyone know that this equation is dimensionally true, dimensionally correct. Now let me verify it by dimension. In this equation, v square is equal to u square plus 2s. V is the final velocity, u initial velocity, a is the acceleration, and s is the displacement of particle. Now, in this example, when we are writing solution of this example or we are verifying the truth of the equation, so we have to do one thing. So we have to write a dimension of this v square, we have to write dimension of u square, and we have to write dimension of 2as. If dimension of all term in the equations are same, then this equation is dimensionally correct. Now let's see. So dimension of v. V is the final velocity. So velocity dimension is m0 L1 t minus 1. So this is dimension of v. So in this equation, v square is there. So dimension of v square. So square of this we have to do. So we get m0 L2 t minus 2. This is the dimension of v square. So this is equation number 1. Now similar manner we can write dimension of u square also. U is initial velocity. So it's a velocity again. So having the same dimension. So u, this is a velocity and the square of that we can take equation number 2. Now similar manner we can write dimension of 2as. So 2 is a number don't have dimension. So dimension of a multiplied by dimension of s. A is the acceleration, s is the displacement. Then we write a dimension of acceleration, which is L1 t minus 2, and displacement L1. After solving, doing a multiplication of these two dimensions, we get a dimension of this term, and it is m0 L2 t minus 2. So t minus 1. So t minus 2. So this L1, L1 is L2, and t minus 2. So this is a dimension. If you see the equation 1, 2, and 3, so dimensions you can see all the similar dimensions. So if from equation 1, 2, and 3, it is found that the terms in a given equations are having same dimensions. Hence, this equation is dimensionally correct. In this similar manner, you can verify the truth of any equation. Now, second example we can see, and it is Example, v is equal to u plus 18. So we have to verify the truth of equation v is equal to u plus 18. Again, it is a kinematical equation. So let me write the dimension of all the terms. So here, three terms in equations are there, v, u, and 18. So we have to write dimension of every term. So dimension of v, it's a velocity, so m0 l1 t minus 1. So equation number 1. So dimension of u is similar to the dimension of v because both are velocities. Now after that, dimension of A2. So dimension of A multiplied by dimension of T. So dimension of A is M0 L1 T minus 2 and dimension of T is T1. After doing multiplication, we get M0 L1 T minus 1. You can see this is equation number 3. So observe the equation 1, 2 and 3 very carefully. So by using these three equations, we can write the dimensions of all terms in the equation are same. Hence, this equation is dimensionally correct. Now, example number 3. See, this is third kinematical equation. S is equal to ut plus half at square. Now, this is a very known equation. In this equation, S is a displacement, U is the initial velocity, T is the time, A is the acceleration. Now, let me write a dimension of S, then dimension of ut, and dimension of half at square. So dimension of S is equal to S is a displacement, so m0 L1 T minus T raised to 0 is the dimension of displacement. Then dimension of ut, dimension of u multiplied by dimension of t. U is a velocity, so dimension is m0 L1 T minus 1 and time multiplied by dimension of time m0 L0 T raised to 1. So after solving this, we get a dimension m0 L1 T raised to 0. This is equation number 2. Similar manner, we can write a dimension of the third term, half at square. Half is a number don't have dimension. So dimension of A multiplied by dimension of T square. So dimension of A, we are written, as well as dimension of T, we are written, and then square of that. Then after this, let me find out square first. Dimension of A as it is, dimension of T square. Then after doing a multiplication of these two, we get a dimension m0 L1 T raised to 0. This T raised to minus 2 and T raised to plus 2. So we get T raised to 0 here. So this is equation number 3. So from 1, 2 and 3, it is found that the terms in the equation, given equation, are having same dimensions. Hence, this equation is dimensionally correct. So remember one thing here. So if all the terms having same dimension, then it is dimensionally correct. In another word, so we can go in a reverse way. So if given equation is physically true, means dimensions are same. So if equation is given S is equal to ut plus half at square and they ask to find out dimension of u, then you know that dimension of S is equal to dimension of ut. So dimension of u, you can write dimension of S divided by dimension of t. So dimension of S divided by dimension of t gives us dimension of u. So in that way also you can find out the dimensions, or you can find out the unit of any quantity given in the equation by using dimension, because you know how to write down unit if the dimension is known. I hope everyone understood the first use of dimensional analysis, which is used to verify the truth of given physical equation. Now let's see some example based on the use number 1, which may be asked in the competitive examination. See this example. In this example, distance is x traveled by body with time t. Time is t, and this is the equation. So this equation is dimensionally correct, and they ask find dimension of A and B. So if we use a homogeneity of dimension or use number 1, so dimension of x is equal to dimension of A, because this is dimensionally correct equation. So we have to write dimension of A. So dimension of A is equal to dimension of x divided by dimension of t. So hence Dimension of A is equal to dimension of X is L1, M0, T0. It's a length basically, it's a distance. And dimension of time is T raised to 1. So after solving this, we get a dimension of quantity A. So L raised to 1, M raised to 0, and T raised to this 0 minus 1, so minus 1. So this is the dimension of term A, and this is the answer. Similar manner, we can find out dimension of B also. Now in that also we can use dimension of X is equal to dimension of BT square. BT square. So dimension of B is equal to dimension of X divided by dimension of T square. Dimension of X is a distance basically. So the dimension is dimension we can write L1, M0, T0, and T square. It's a time square, so T raised to 2 we can write. So L raised to 1, M raised to 0 as it is, T raised to 2 shifted up, T raised to minus 2. So this is the dimension of B. So this type of question may be asked in competitive examination about a dimension of any term. So you have to be ready for that. Thank you for watching this video. If you really like it, don't forget to subscribe my channel as well as press notification bell to get latest update. Thank you.